Hi everyone, welcome back to another exciting trig lesson. Today we're going to learn how to write an equation of a trig function from the graph or even from a word problem. The graph of sine and cosine are what are called sinusoid functions. When you write a sine or cosine function for a sinusoid, we basically need to find the values of a, b, and d. Now, ironically, we actually don't need to find the value of c at all because c is just a left and right translation. It's basically called a phase shift. And a phase shift is not needed because instead of saying, oh, we need this negative cosine function with a phase shift, what we do instead is just call it a different part of the graph because all the sine and cosine functions basically line up to each other. So each one is just kind of a phase shift of the other one. So we don't need to find the phase shift. So we have the two main forms of sine and cosine just without the phase shift in them, where we have A, which is our amplitude, B is the change in the period, and then D is the vertical shift. So A is the amplitude, 2 pi over B is our period. So we can actually find B by doing 2 pi divided by the period of the function. C is the horizontal shift, we don't need, because all of these are just translations of each other. And then D is the vertical shift. So the way we write our trig function model, I have the steps for us listed out here. So the first thing we want to do is we want to identify the maximum and the minimum of the function, because if we can find the maximum and minimum, then we can find the midline. So first thing I'm going to do is just figure out where is my highest point and where is my lowest point. So when I look at this graph here, I can see this highest guy is the maximum. There's a maximum at 4. And this lowest guy down here is the minimum at -4. Okay. Minimum. There we go. So first thing I'm going to do is find the midline. Okay. The midline was basically, normally it's at 0. We can actually see on this one that it is at 0, but I'm going to have us practice doing the calculation on this one. So for the midline, step 1, find D, which is the midline. D is found by doing the maximum, which was 4, plus the minimum, which is -4, divided by 2. You're basically just finding the average between them. 4 plus -4 is 0, divided by 2 means that D of our equation is 0. So we found one variable in our equation. Second thing we're going to do is find the amplitude, which again, you can probably figure out the amplitude from this pretty easily. It's the maximum minus the minimum divided by 2, but you can probably see the amplitude on here, but just in case, because when we get to word problems, you're not going to be able to see the amplitude as easiest. For us, we know the amplitude is the distance between the midline and the highest point. But if you did need to calculate the amplitude, that's the variable A. You're going to find that by doing the maximum minus the minimum. So that would be 4 minus -4 divided by 2. That would be 8 divided by 2, which is 4. So A is 4 on this one, which again, we could probably see just by looking at this because the distance between the midline and the highest is 4. Okay, next up, we're going to figure out how long the period is. To figure out how long the period is, you're basically looking for the distance between like a peak to another peak, or a trough to another trough, which is like the lowest point, or like the same position repeating over and over. So I'm going to see, I have a trough here, trough meaning lowest point. So like lowest point to lowest point. So my period would be, let me do it in a different color. My period would be this distance right here is the period. Okay. So we got to figure out that distance. So that distance goes from 0, and then this would be 2 pi over 3. If this is 1 pi over 3, then this is 2 pi over 3. 2 pi over 3. Okay, so this is bringing us up to step 3. We are identifying the period so that we can use it to find B. Period is going to be 2 pi over 3. Okay. And now once we know the period, then we can go back and calculate what the B in our equation is. It's basically, we calculate it opposite of how we normally calculate the period. So the B value is going to be 2 pi divided by what we just found for the period, which was 2 pi over 3. Remember, when you're dividing by a fraction, you're going to keep the top the same, switch it to multiplying, and then flip the bottom one over to get its reciprocal. Those 2 pi's would cancel because they're diagonal, and your B would just be 3. And then last thing we got to do is decide whether this is a sine or a cosine graph. So I kind of just look at one cycle of it starting at 0. So I can see one cycle of it starting at 0. Starts from the lowest point, comes up, and then goes back down to the lowest point. This is not a sine function. A sine function starts at the midline. So we know it's not going to be one of the two that are starting at the midline. This is going to be basically opposite of our regular sine function, because usually our sine function looks like this, but ours looks opposite. So we want to use negative cosine. Okay, so what I'm going to do is I'm going to write out just the blank negative cosine equation. So instead of saying y equals a cosine of bx plus d, I'm just going to make that a negative. Negative a cosine of bx plus d. And then we're going to fill in those variables that we just found. We found our amplitude was 4, so we're going to write negative 4. Cosine, we found our b value was 3x. And then our d variable, the vertical shift, we didn't vertical shift at all because our midline was still at 0. So I'm not going to write the d variable on this one. We'll just leave it as negative 4 cosine of 3x. I forgot I wanted to write the word period here. Okay, that wasn't too bad, was it? Especially opposite of what we've been doing with graphing. Okay, so we found the midline, we found the amplitude, we figured out the period, and we found b, and then we decided whether it was sine or cosine, and then we wrote our equation. Let's try another one. The first thing we're going to do is identify the maximum and the minimum. Okay, so I can see my maximum is up here. My minimum is down here. Okay, so maximum is at 5, and minimum is at, this would be negative 5, negative 10, negative 15, which you can see in the point here. So from there, we're going to start by finding our midline, which you could probably see on the graph, but just in case, you can also calculate it by doing your max plus your min, 5 plus negative 15 divided by 2. That would be negative 10 divided by 2, which is 5. I'm gonna write d equals 5. And you could probably see that on the graph. Sorry, that would be negative 10 divided by 2, which is negative 5. And again, you could probably see that that midline was at negative 5 on the graph. Your midline, remember, is just the middle, literally the middle of your graph. So our midline would actually be right here. Midline. Okay, and then from there, we can find our amplitude. Again, you can kind of do it one of two ways. You can use the equation right here, maximum minus minimum divided by 2. Or you can also just look at your graph. So my amplitude is going to be the distance between my midline and my highest point here. This distance, it's always a positive number. But if you can't see it on the graph, remember, you can calculate it by doing your maximum minus your minimum divided by 2. That would become 20 divided by 2, which is 10. So my A is 10. Okay, identify the period. Again, for the period, you have to look at basically from the same point to the same point, or a highest part of the graph to a highest part of the graph, or a trough to a trough. I'm going to do this highest part to this next highest part here. What color did I do that in? So I'm going to do from here to here. This is our period. And then I just have to figure out what distance that is. So it goes from 0.5. Each of these is 0.5. So this would be 1, 2, 3, 3.5. So from a distance of 0.5 to 3.5 would be a period of 1, 2, just 2 units. Period is 2 units, not 2 pi. They're not labeled on pi. They're just units on this one. From there, we can calculate our b. B is going to be 2 pi divided by what we just found for the period. So that's 2 pi divided by 2, which is pi. Okay, now we need to decide on what type of graph it is. So where is it starting from? So you can actually see on this one at the y-axis, it actually starts at the midline and goes up. So if we look at just one cycle of this is actually just a regular old sine function, because it starts at the midline and goes up. If it started at the midline and went down, that would be basically negative sine. But ours starts at the midline and goes up. which looks like this guy here is just regular sine. Just regular sine. So it's going to be this regular equation, not negative or anything. I'm going to write down that regular equation with its variables. No negatives or anything. And then I'll substitute in all the variables I just found. My amplitude was 10. My b value was pi, so in my parentheses, it'll say pi x. And then the vertical shift was down 5, so we would write -5 for that graph. All right, let's get into some where we have an application. Now, this next one is nice because they at least give us a graph to look at. They don't always give us a graph. So we want to write a trig function to model the average daily temperature in Birmingham, Alabama. And you can see this is a little sinusoid wave. Starting by, I'm going to identify the maximum and the minimum. Okay, so my maximum is up here at 80. And my minimum is down here at 40. From there, remember, you can find your midline if you can see it on the graph. That's great. If you can't see it on the graph, you can also calculate it. The midline, remember, is D. And that's found by doing the maximum plus the minimum divided by 2. So that would be 80 plus 40 divided by 2. So that would be 120 divided by 2, which is 60. So D is 60. That is where your midline is. If you want to draw it in, you're welcome to. Here's where our midline is. Okay. From there, we want to find the amplitude, which you might be able to see on the graph. If you can't see it on the graph, remember, you can also calculate it. The amplitude is simply just the distance between the midline and the highest, or the midline and the lowest. On the graph, you can definitely see that it goes from 60 to 80, so that's a distance of 20. So we know the A is going to be 20. If you need to calculate it, though, it would be the maximum minus the minimum divided by 2, which would be 40 divided by 2, which again is 20, what we just found. Up next, figuring out what the period is, because we need the period in order to find B in the period. Again, to find the period, you need to look for basically the lowest point to the lowest point or the highest point to the highest point. And I see this lowest point here and this lowest point here. So this entire distance from here all the way over here, this lowest point is going to be the period. So if you look at what that x distance is, that would be over here at 12. So our period is 12 on this one. And then once we have the period, we can use the period to find b. b, remember, it was just 2 pi divided by your period. So that would be 2 pi divided by 12, which you could reduce and get pi over 6. Okay, and then lastly, figuring out what type of sine or cosine it is. Okay, so remember our options: regular cosine looks like this, upside down cosine, negative cosine goes the other way, and then we have original sine, and then negative sine, which would start by going down. So ours looks like a cosine function for sure, and it does start and go upwards, and if it starts and goes upwards, then that means it's the cosine but negative. So I'm going to write down this cosine equation, but just make sure A is negative. I say y equals negative A cosine of bx plus d. And then we'll fill in what we know. A was 20, so that's negative 20 cosine. B is pi over 6, so we would write pi over 6x. And then our vertical shift was up 60, so we would say plus 60. All right. Do we have graphs on the back? Oh, I'm taking them away. No graphs on the back. Gotta do it regular style. All right. Ferris wheel has a minimum height of 2 and a maximum height of 50. Well, that's going to help us figure out our vertical shift and our midline. It takes 40 seconds to complete one full rotation around the wheel. Okay. At a time of t equals 0, the writer is at the lowest point. Going to help us figure out what the graph looks like. write a trig function to model this. So first thing I'm going to do, start just like I did on the front. I'm going to find the midline. The midline is basically the maximum plus the minimum divided by 2. Maximum plus the minimum divided by 2, which we know the maximum. The maximum was 50, and the minimum is 2. They spelled it out for us. So we'll say 50 plus 2 divided by 2. I have to write in D. So that would be 52 divided by 2, which is 26. So the midline is at 26 on this one. The amplitude, since we don't have a graph, we'll have to calculate it using the formula, which is basically the same as this one, but subtracting. It would be the maximum minus the minimum divided by 2 for the A value. That would be 48 divided by 2. So our amplitude on this is going to be 24. Now the period, since we don't have a graph, we're going to have to use a little bit of common sense. Okay. So when it says it takes 40 seconds to complete one full rotation around the wheel, that's basically telling us the period. It's telling us that it takes, you can make one cycle of whatever this trig function is in 40 seconds. So this is meaning you can do one cycle of your trig function in 40 seconds. And if you can do one cycle in 40 seconds, then your period is 40 seconds. Because period is the x distance it takes to make one cycle. So our period is 40. And then once we have the period, we can use the period to find b. b was calculated by doing 2 pi over the period, which for us was 40. And this will reduce to 1 and a 20. So our b value is pi over 20. And then lastly, figuring out what type of trig function this is. So right here where it says at a time of t equals 0, the writer is at the lowest point. So to think about what trig function that is, we need to look and see which one of these starts at the lowest point. Well, it can't be sine or negative sine because both of these start at the midline. Starts at the midline, goes up, starts at the midline, goes down. But for regular cosine, it starts at the highest point and goes down. But for negative cosine, it starts at the lowest point and goes up. And ours, as they said, is starting at the lowest point. And if it starts at the lowest point, this has to be negative cosine. So I'm going to write my blank negative cosine equation with all of its variables. Negative a cosine of bx plus d. And then I'll substitute in the ones I found. So for my a, that would be negative 24 cosine. My b was pi over 20. And then my midline had a vertical shift up 26. So on the word problems, you kind of have to make a little puzzle that you're putting together with all the little clues they give you. Okay, same thing on the next one. The next one's talking about ocean tides, though. The height of the ocean tides varies from 2 foot to 10 foot over a 12-hour cycle. So they're telling us a maximum and the minimum there. Okay, right here, it completes one cycle in 12 hours. Think about what they're telling us there. And at a time of t equals 0, the tide is at its maximum height. It's giving us everything we need, just in a cryptic form. Okay, so starting with our midline. Remember, midline is your highest plus your lowest divided by 2, which they told us right here. These are our lowest height and highest height. So that would be d equals 2 plus 10 divided by 2. That's 12 divided by 2, which means d equals 6. There's going to be a vertical shift of 6. The amplitude is basically the same equation, but minus. Amplitude. So amplitude is maximum minus the minimum. 10 minus 2 over 2. Sorry, on this top one, I wish I'd written 10 plus 2. I know it's the same thing, but it's nice to see the max first. Max plus min divided by 2. Okay, 10 minus 2 divided by 2, that would be 8 divided by 2, which means our amplitude is 4. Our period, they told it to us in a very cryptic way. They said over a 12-hour cycle, which means we're going to make the whole sinusoidal function in a 12-hour cycle. One cycle in 12 hours is what this is hinting to us. One cycle in 12 hours, which means that is our period, because we can do one of the whatever trig function in 12 hours. Period is 12. And once you know the period, then you can calculate b, because b is just 2 pi divided by your period. Divided by 12, which would simplify to pi over 6 for our b. And then figuring out what trig function this is. So the fact that they say it starts at its maximum is what's going to help us. If it had started in the middle, middle would be a sine function, because sine functions start at the midline. The only one that starts at the maximum is going to be regular old cosine. Regular old cosine starts at the maximum. I'm going to write down just regular old cosine equation, not negative cosine. And then we'll substitute in what we know. A is 4. B is pi over 6. And the midline shift was up 6. There's our beautiful trig function. All right, we're back to another Ferris wheel. I feel like there's a lot of Ferris wheel questions when you're talking about making a trig function graph. It says a Ferris wheel with a radius of 25 feet is rotating at a rate of 3 revolutions per minute. Okay, Ferris wheel with a radius of 25 feet is rotating at 3 revolutions per minute. When t equals 0, a chair starts at the lowest point on the wheel, which is 5 feet above the ground. Write a model for height in feet of the chairs as a function of time in minutes. Okay, so let's see. I am told that we're starting at the lowest point. Okay. What color did I highlight this in? But it does say the lowest point is 5 feet above the ground. Okay, feel free to label that on your graph here. The lowest point is 5 feet above the ground. Now, they did secretly tell us the highest point. They just didn't spell it out. Okay. To find the highest point, we're going to need to use the fact that the radius is 25 feet. Okay. So my lowest point was 5. This radius would be 25. We'd have another radius, which would be another 25, making this maximum highest point here, 25 plus 25 plus 5. There's a max at 55, a minimum at 5. So they secretly tell you the maximum and the minimum. Okay? So from there, we know already that we can now find the midline and we can find the amplitude. Okay, so doing midline. Okay, midline again is your maximum plus your minimum divided by 2. So that would be 55 plus 5 divided by 2, which is 60 divided by 2, which means your midline is 30. Okay, we can also find the amplitude. Your amplitude, remember, was your maximum minus your minimum divided by 2. A equals 55 minus 5 divided by 2. So that would be 50 divided by 2, which is 25. Okay. Now to figure out the period, we got to think a little bit. And the period is tricky on this one. It says it's rotating at a rate of 3 revolutions per minute. Okay, that does not mean one cycle in 3 minutes. Okay, that's not what that means. So what I had to do when I thought about this is I thought about what this graph looks like. Okay, that means it's going to make 3 sine or cosine functions. It's going to make, it would make 3 sine or cosine functions in 1 minute. because every revolution here is going to make another trig function. So this would make one trig function, another trig function, another trig function in a distance of 1 minute. So if you think about what that would look like, let me just kind of show you. So it would make, let me see, we know we're starting at the lowest point. So this would be the upside down cosine. So it would make one upside down cosine, another upside down cosine, and another upside down cosine in a distance of, this whole thing is 1 minute. But period is the x distance it takes to make one cycle. Okay. So my period is actually just this distance right here. This is the period. The x distance it takes to make one cycle. And this x distance to make one cycle is 1/3 of a minute, which is 1/3. Period is 1/3. Okay, that was tricky. That was the trickiest I think the period gets. So where did I put my pencil? There it is. Okay, so for our period, we just figured it out. If it was 3 cosine functions in 1 minute, then the period of one cosine function would just be 1/3 of a minute. And then once you know the period, then you can find your b value. B, remember, is found by doing 2 pi divided by the period. 2 pi divided by 1/3 would be the same as doing 2 pi times 3/1, which is 6 pi. Right, b equals 6 pi. B equals 6 pi. And then from there, we can write our equation. Okay. Again, I already kind of decided that since the chair was starting at the lowest point, that has to be one of the negative cosines. So that's the only one that starts at lowest point. Everything else, sine start at midline. Regular cosine starts at the highest point and goes down, but negative cosine starts at the lowest point. And that's what they told us, that we are starting at the lowest point. So we know we're going to need the negative cosine. And then we'll fill in what we know. So for the negative a, we'll write -25 cosine. Our b was 6 pi, so 6 pi x plus our vertical translation d. Oh, I should actually probably write d, 30. Okay, one last one. The last one comes from AP Classroom. So it's multiple choice. Let's read it. Okay, a wind turbine consists of a 212-foot tower with 3 blades. Each blade is 116 feet tall. The turbine makes 1 revolution every 4 seconds. 1 revolution every 4 seconds. So that's going to help us find our period. At a time of t equals 0, the tip of the blade A is at its maximum height of 328 feet. Okay. At a time of t equals 0, the tip of the blade is at its maximum height. And then they told us the maximum height is 328. I'm going to put that on my graph. Maximum is up here, is 328. Okay. Which of the following best models the height in feet of the tip of the blade A from the ground t seconds after the turbine begins to run? Okay, at least it's nice. We already know that it's a cosine graph. Okay, that's nice. But best part about multiple choice. We got to figure out the amplitude though, the b value and the d value. Okay, so we know the maximum height is 328. We need to probably find the lowest height now. Okay, the lowest height is going to have to do with the fact that we know that right here is 212, and then each blade, that's the lowest the blade is going to go. How long is the blade? The blade is 116. So if we take 212 and subtract off this blade amount of 116, that's 212 minus 116. 212 minus 116. 96 is going to be our lowest. Right here, 96 is the minimum. Once we know the max and min, we can easily find our midline and our A value. Midline. That's D. D is found by doing maximum plus minimum, 328 plus 96 divided by 2. 328 plus 96 divided by 2. Let's do it. 212. Based on that, I can mark off 2 answers. B and D have the wrong midline amounts. So we know it's not B, not D. Okay, narrowing it down. Okay, both of these have the same A, so I mean, I can already tell A is 116. We don't even need to calculate it. A is 116. So we probably do need to find B, and in order to find B, we have to find the period. The period sounded like it would be as confusing as the last one, but it's not. 1 revolution every 4 seconds means it is 1 cycle in 4 seconds, which is the period. The period is always just the x distance it takes to make 1 cycle. So our period is simply just 4. And if we know the period, then we can find B. B, remember, is 2 pi divided by our period of 4, which would simplify to B equals pi over 2. And the only leftover answer that has pi over 2 in where B is going to be answer A. All right, I hope we learned something today.